I guess I'll go ahead and get started then. I noticed in your video one specific issue you had issues with was the not pressure sealed enough for a payload deployment. I was wondering if you could go into that in a little more detail and explain how you discovered that issue and what led you to resolving it.
Maddie, do you want to take that one?
Yeah, so initially we had pretty large holes in both of our bulkheads for the sled to slot into. And when we were looking over all of our data from the Ravens after flights, we realized that it was really feeling the effects. So we knew that a lot of the pressure was coming into the E-bay instead of the upper body tube where we wanted it to be. So we ended up changing how the sled mounted inside of our E-bay. So it was on the threaded rods now that ran through, and the only holes in our bulkheads are just the wire penetration holes now. Everything else is sealed up. So that made things start working a lot better for us.
That makes sense. I have some general questions too I'd like to ask. One, obviously we're not in Spaceport America launching this week, which is unfortunate, but I want you all to imagine for a second that you are there at the spaceport and you're preparing your rocket in 105-degree heat in the Chihuahuan Desert. What goes wrong in your assembly procedure, and how do you address that?
Miles, you want to take that one?
Sure. So some stuff that could go wrong. Some issues that we had in the past were black powder charge sizing. So that could be an issue with assembling it and making sure that those charges are correct. We will, at the competition, we will have done injection tests beforehand. So that may not be an issue there. Another issue could be that we didn't bring all our parts with us because we would have been traveling there, so that could arise as well. Other than that, if we misplaced things or didn't keep track of stuff or organizational issues, that could also arise. Anyone else have anything to add?
I would say, oh, you can go ahead, Ben.
Yeah, I would just briefly add another issue that might arise for us, especially in the rush of competition and the excitement, would be wiring faults on our end, some miswiring issues, or that something along those lines are definitely an easy thing to happen if not properly accounted for.
That's exactly what I was going to say.
And then to build on that question, when you actually get to the launch rail and launch the rocket, what is the most likely way it's going to fail during its flight?
I think the most likely way it would fail is in recovery, because we've had a lot of issues with that in the past, and that is sort of what influenced our design, because we went through a couple of designs and tested them. And so our design right now has been our most successful in the past. However, working with like GPSs and making sure the parachutes actually that has been our greatest challenge, and so that is probably the thing that will most likely go wrong during flight.
And so you think the failure mode will be what of the recovery system?
I would say the GPSs.
So you won't be able to find it after?
Correct. So there's been a couple of times where we saw it like drop down, or like, yeah. But we weren't actually able to locate it because of GPS failure, whether that be batteries running out, or the GPS is just not communicating with our on our end. So there's a couple of issues there that we're still working out, and we're also testing out different brands of GPSs, and so that's one of the main things we're still working on.
I'd also just add that from our payload recovery perspective, our risk analysis put a the highest chance of failure along the lines of a main parachute failure to deploy. So in our case, the parafoil doesn't come out, and then our payload's just falling on its drogue chute for the whole descent.
I did have a related question to that parafoil. How did you choose the NACA 4418 airfoil? Is that common to parafoils, or is there a decision process you went through there?
Want to take that, Ben?
Oh yeah. So in paper, I scrolled through a lot of papers in the initial design phase of the parafoil, and I found historically in traditional parafoils, when they were first being developed, the Clark Y, I believe, which is a pretty traditional airfoil section, was pretty commonly used for low performance parafoils, which due to its simple shape was pretty easy to look into fabrication of and creation of. There's more modern ones that have a little more complicated shape. And then specifically the NACA 4418, I picked as it has a quite a similar rough section as the Clark Y, but it was more easily built into Xfoil, which I used as my airfoil analysis software. I had some difficulty there getting the coordinates into Xfoil of the Clark Y that I was interested in. So I instead went with an equivalent built-in airfoil section from Xfoil, which I think should work or works reasonably well as an equivalent there.
And I didn't notice if you had any videos of it parafoiling down. I know you did some ground tests. Do you have any deployment at altitude tests yet?
Unfortunately, no. Due to development with the pandemic and our university status, we had a much slower development schedule than we would have liked this year. So we weren't able to achieve any from altitude tests or any drop tests on that regard. We've mainly focused on development of the wing itself, of the parafoil itself, inflation, packing, standard procedures for that, just so we could develop our baseline functionality of it, and then move on into real world testing and get that ready to go.
And then I do want to ask, so we went over a couple of the failures, and you have some work to do yet to perfect your vehicle. Looking forward to next year's competition, how is your team going to transfer the information that you have now and the lessons you have learned to ensure that the whether it's you or other people coming along, are able to compete successfully next year?
So something that we really tried to work hard on this year was documents with everything we've done. So we have design decision documents, and we have spreadsheets with all of our calculations, and also explaining how they were done and where we got those resources from. And so all of that is kept in Google Drive. And so we have an archive of every year. And so for the work that we did this year, sometimes we look back at previous years, and then next year we'll look back at this year to see what we did. And also having written the paper that is full of resources of how our rocket worked. And so we also use SolidWorks PDM, and so we can access all of the SolidWorks files from previous years.
Could I add a word as well?
Mhm.
In also for like certain calculations that we do, or for certain softwares that we will use in our calculations, we have documentation for those, as well as like how they work and how to use them, and stuff like that, just to make sure that that information gets passed along as well.
All right. I have one final question, but I just want to see if Mark or John have anything they'd like to chime in with.
Just to start off, is this team 14 or 145?
14.
14, okay. So about the parafoil guiding it to the ground, do you have an active control system on that, or you just set a constant bank angle?
Zach, you want to talk about that?
Sure. Yeah, we have an active control system that accounts for real-time data. And it's split into 2 stages. So we have a holding phase at higher altitudes, and then once we get to once we meet certain conditions like the altitude and the payload's facing the right direction, we begin a second phase for descending to the point.
And that follows a guidance path that we generate at like a what's a good word for that, Zach? A
Sinusoidal path?
Yeah, a sinusoidal, like predetermined sinusoidal path we generate on the field there that allows us to adjust our pathing distance, and that gets followed with a pure pursuit model, correct?
Yeah.
And maybe a little more about the control system itself. Are the shroud lines actually changing length to tilt the parafoil?
Yeah, I can talk about that, Zach, quick. So we have control lines coming down from the trailing edge of the parafoil on either side. It's on either the quarter edge of each trailing line. We have control lines coming down to the parafoil itself, to the top section, where they meet up with 2 motors that are then controlled by our flight board in there. So we're using those to bank purely. So we're always doing asymmetric deflections of the wing. We found that it was too difficult to model any symmetric deflections for any angle of attack changes or glide ratio changes. So we're just purely altering our bank angle for turns for the vehicle. And that seemed to be a fairly modelable scenario there.
Okay. Different question on your team. Now that you've basically completed the project, do you feel that the members of the team were well occupied, or was there some areas that were a little too heavy and some that hardly did anything?
I think from an overall team management perspective, I think the project went much better than my expectations going into the year with the pandemic kind of looming over everything. I think we definitely learned some lessons to take forward for the next year about kind of managing our testing of our various assemblies. But I think that overall the rocket, the test rockets we ran and the final model we ended up was one of the best that I think we've ever done on the team. So.
So that's the rocket itself. I'm wondering more about the team members. Does any particular team member feel underused or overused?
So I was airframe lead, and so in terms of airframe, we had a few core members that did majority of the work, and then we had others that didn't want to spend as much time. And so it was more based off of how much a member is willing to commit. So I would assign tasks based on that. And then if someone had too many tasks, then they would let me know and I would reassign it. So it's sort of based on individual preferences. And so we were able to balance it out that way.
Okay.
On the payload side of things, we had a pretty well split up workload, but I would say that on the software side, we put a lot of the work for the programming onto 2 people, and that did slow our progress in our testing somewhat, but we're looking to improve that for next year.
Okay, I got a question. I know the motor you selected was a M1450. Is that one you've used before?
No, we have not.
Okay.
What is the largest motor that the members of your team have launched at this point in time?
We have launched L motors.
I forget, does anyone hold a level 2 rating with NAR or Tripoli?
I do.
Yes, we have, we're in this call, we have Ben, Sebastian, myself, Maddie, and Max, who are all level 2, and a few other members on our team as well.
One question I want to ask for a kind of a wrap-up thing is there any aspect of your project that you want us to know that you might not yet have adequately discussed, that you have this opportunity to tell us about?
Can I jump in with one quick? I think it's pretty neat. I don't know how common it is since we're a very fresh team to this competition, but I really think it's sort of speaks to our team. We have these homemade like tender descenders that we use that are just sort of our own, made from scratch. And I don't think we cover it too much, but I just think it really kind of speaks to our team, how we function, where if we find a problem that doesn't really satisfy our needs, like we'd used commercial off-the-shelf tender descenders in the past, and they had frustrated us. They caused problems with how our specific team members had worked in the past. So to instead of just like bearing with the problem and continuing to use those, we really found, we were like, okay, let's just develop our own system then that really suits our mindset. So we built ones that specifically mounted onto the bulkhead. They worked exactly how we wanted. They'd be cheaply manufacturable for us since we're often budget constrained. And I think that really speaks to how our team functions in solving problems, of adapting situations that might have slowed us down in terms of assembling the rocket on the day of the launch, or in terms of manufacturing costs. I think that speaks to how our ability to sort of conquer those problems in our own sort of unique way.
All right, very nice.
One other thing we started to experiment more with this year too was in our eBay. We got really interested in doing more weight relief there as much as we could. So we got really into different weight relief patterns on the CNC and different ways we could save weight there, because it seemed like there was always more weight to shave off, and that's always been a problem for us as well.
Very nice. John and Mark, I've concluded the questions I have for this team.
Okay, no, I like the presentation. I watched the video several times, and I was just kind of curious on the video, how many times did y'all practice or do a dry run on the video before submitting it?
So I was the one who edited the video. We recorded actually about 5 hours of footage that we cut down. But yeah, I would sit down with our team members and kind of work through just talking about the systems and take it from there.
Cool. Yeah, I liked it when you did the when you ran with the parasail testing at the parachute release system. I thought it was entertaining. So I like that.
It was a very cold Cleveland wintry day when we did that. I'm wearing like a parka basically out there. That was just sort of a spur of the moment thing we recorded, and I'm glad it got to be used.
Yeah, it's good to have a little bit of comic relief in there. So I like that. That's all I have. I like the presentation, and thank you very much for your time.
Thank you.
Thank you so
Thank
much.
you.
Thank
Thank
you.
you very much.
Thank you all.
Thank you.